Okay, so this is the first of 2 days we'll be talking about 6.1.4, and this is triangle congruence flowchart proofs. So you guys remember flowchart proofs back from chapter 3, kind of? Look at the thing down on the bottom. Does it kind of look familiar to you? Okay, so we've seen these before, but these are going to be a little bit different. A couple of things that are going to be different. Number one difference is beginning today, every bubble that we put into a flowchart has to have a reason next to it. Now, back in semester 1, remember I made you put a reason only on the conclusion bubble, only on the last one. That was just so that we could kind of simplify things a little bit and get you used to the idea. But technically, anytime you do a proof, every single bubble needs to have a reason. Okay, so we're going to be writing some more reasons. Other than that, it's basically going to look like what we saw last semester. So let me show you a couple new reasons that we will be using today. And they are given the reflexive property and vertical angles. That last one should be very familiar to you, right? Can you picture a set of vertical angles right now? What school supply do you think of when you think of vertical angles? I think of scissors, right? Okay. So we saw this last semester, and you guys got pretty good at recognizing that whenever you saw these tick marks on two sides, what did that tell you about the length of those two sides? They're equal. It's the same length, right? Now, if we ever use that in a proof, and that tick mark was there when we started the problem, meaning it was on the original problem, then our reason is going to be given. Okay. So if it shows up, if it comes as part of the problem, the reason you're going to use is given. Same idea here. Look, see how these two angles have these arcs? You know that those arcs mean that those two angles are congruent. They're the same size, right? Those arcs are given to us as part of the problem. So our reason for saying those two angles are congruent, we would say given for those. So if it appears in the original picture, your answer is given, or your reason is given, okay? There's a couple other things that pop up. When we were doing our flashcards the other day, I had a lot of people that were really good at recognizing this one. And I asked you to kind of start saying in your head this word. How many people were saying reflexive property when they were doing those the other day? Anybody do that? I'd be glad you did today. All right, so this happens when you've got this shared side. If you've got two triangles that both share a side, anytime we write something where we say that something is equal to itself, that's our reflexive property. Most often right now, for what we're doing today, this is going to come up when you've got a shared side. Okay, now usually when we're doing these problems, we'll mark them as congruent. I'm kind of doing it with a dash line just to kind of show it wasn't originally marked in the picture. If it was originally marked in the picture, what will we have used instead of reflexive property? Given. When it's marked in the picture, in the original picture, it's given. This one was not marked, but we do know that it's equal and we can mark it because of that shared side. That's our reflexive property. This one's probably going to be the one that's going to take you the longest till you get really comfortable with, because it's kind of the new one for us. All right, last one. We've seen this so much in first semester, vertical angles. So I've got a picture here of two triangles, and even though this angle right here and this angle right here were not marked originally, I know that they're equal. And I know that they're equal because they are vertical angles, and vertical angles are always equal. Okay, so we will be using vertical angles a lot for our reasons. All right, any questions, comments, concerns up to this point? You guys are doing great. I'm about to give you a task here. Okay, use your pencil if you're not sure. I got a proof down on the bottom. Now, this proof is 100% correct. It's a beautiful little proof. I would like you to figure out what my 4 reasons are. So what are going to go in those blocks numbered 1, 2, 3, 4? And by the way, we don't usually number these boxes. We usually don't even draw the boxes, but just for our notes today, we are. So see if you can figure out what goes in there. And I'm going to give you a hint. Okay, look up here for a second. The top 3 are going to be one of these ones that we just talked about. The top 3 reasons are going to be one of these. Now, not every one of these is going to get used, but they're going to be something from these 4, okay? The bottom one is going to be one of our conclusions that's in our yellow packet, those 5 things Remember, I told you to get your yellow packet out. This is the reason why. Okay, so go ahead and go through there. And I would love it if you would have a little discussion once you get done with the person sitting near you. See what they got, see if you agree. All right, take a moment and do this. While you're doing this, I'm going to go ahead and stamp a couple of rows worth of homework. So if you guys could have that bright yellow sheet in your homework packets out, ready to go. Okay, be back with you in a sec. Okay, now this is one of the things that some of my students struggle with. So please pay attention here real quick. Were you guys able to figure out what I meant by angle WYX? Do you remember that from first semester? That is the angle that you always look at the middle letter first, right? The middle letter tells you where the angle is. So that is the angle at W that at Y. Now notice there's two angles here at Y. Well, this is the one that opens up towards W and X. So from Y towards W and Y towards X, we're talking about that angle right there. Now this is going to be a skill you're going to need to have under your belt. So make sure you're paying attention here. Okay. In fact, on the back side of this, I'm going to give you a problem. You're going to have to fill these out. All right. So I need you to know when you see X, Y, Z, that's the angle that's at Y, that's opening up towards X and towards Z. That would be this angle right here. Are we feeling good about that? Naming angles? And can somebody remind me why I can't just say angle Y and angle Y here? What's wrong? Why am I forced to use 3 letters for angles in this one, but I was able to get away with only 1 here? Good. Yeah. So when you look at Y here, if I said angle Y, would you know whether I was talking about the red one or the green one? You'd have no idea. In fact, I might be talking about not either of those, but the big one that's the red one and the green one put together. There's 3 different angles at Y. So if all I say is angle Y, you don't know which one I'm talking about. So that's why I have to use 3 letters so that you can tell exactly which one I'm talking about. Now, angle W and angle Z here, I can only use 1 letter on those if I want, because if I say angle W and you look at this picture, you know what angle I'm talking about. There's no other angle except for this one. Okay, so we good with when we use 3 and when we use 1 for naming angles? Follow up to that? That is a wonderful question. I was hoping someone would ask that. Thank you. Could we use 3 angles always? You guys remember the answer to that question? The answer is yes. You can always use 3 angles. So if you're ever unsure, go with 3. All right, you can never go wrong using 3 letters. Okay, you can only use 1 letter in special circumstances, but you can always use 3. Awesome question. Thank you for that. Any others before we move on? We still haven't written our reasons here. How did I know that this red and this green angle were the same size? How did I know? Because they were marked congruent when we got the picture, right? And our reason for that is going to be given. How many people are given there? Oh, you guys are great at this. All right, W and Z. How did I know that these 2 angles were the same size? It was given to us by those markings. All right, this next one, ooh, this is a dead giveaway. Notice it's the same thing on both sides. It's like YX is looking in the mirror at itself and seeing its reflection. That's our reflexive property. So if you're going to abbreviate this, REFL is fine. Give me 4 letters in each of them. Ruffle prop. Don't just write RP though, because there's a lot of things in math that could mean. All right, now that I've got that reflexive property in, I'm going to go ahead and mark this side because it's going to help me do the next thing that I need to do. All right, I got a follow-up question. Now that I've marked this side, could I go ahead and use given instead of reflexive property? Is given for any side or angle that's marked? No, it's for any side or angle that's marked at the beginning of the problem, not after I've added additional stuff. Those don't count as given. It has to be given to us. Yeah, this was not given to us. We had to think about the fact that this was a shared side. We worked for this. It was not given to us, right? Okay. So for this last one, I'm going to use our little trick here. Let's cover up one of our triangles and just focus on the other one. And when I take inventory here, I notice that I have one side and two angles. So that leaves me a couple possibilities. It's either angle, side, angle, or angle, angle, side. That's the only two that has two angles and a side. Which one is it? Angle, angle, side? Because the side is only touching one of the two marked angles. Is that what's going on in the picture? The side is only touching one of those two marked angles. I agree. This is angle, angle, side. And don't forget, it's angle, angle, side congruence. That's got to go after it. If you just write AAS on a test, I would have to take off like a half a point. All right, on your thumb meters, can you guys show me where you're feeling after this first one? Keep in mind, this is only our first one. So I'm expecting kind of in, good. We're in the learning phase. I'd say right now, anywhere in this range is going to be pretty good. Okay, let's see if we can get another one done here. Flip it on over. Some of you have already started working on the back side, and that's great. I'm going to ask you guys to do the same thing with this one. So work through it and make sure when you get to these ones with the angles that you're actually figuring out where those angles are in the picture. Give that a shot. I'm going to come around and stamp a couple more rows of homework, and then we'll come back and talk about this one. Okay. I'm gonna locate these things here. So MO is this guy here, and OQ is this one right here, and we know those are the same because they have tick marks. So our reason is given. It was told to us. It was shown by the picture. All right, angle MOP. That would be the angle at O opening towards M and P. They're talking about this one right here. And angle NOQ would be this one right here. Now, those were not given to us. I just marked them, but they were not originally marked. So we can't use given. How did we know that they were the same? Because they're vertical angles. And then our last statement here is PO and NO. Let me find those POs here. NOs here. Yep, those have double tick marks. It was there at the beginning, so given. All right, then our last thing to do is to figure out which of our 5 reasons we could use to show these two triangles congruent. Covering up one of them, when I look at one of my triangles, I have 2 sides and an angle. I'm thinking side, angle, side. Is that what you guys thought? Does this work for side, angle, side? The angle is touching both of the sides. Side, side, side. I'd say we don't have enough sides here. I don't know anything about this side MP just yet. Oh, you're classifying this as a side? Okay, so I have a different classification for that than you. I would call this a vertex or a point. A side is it's a straight line segment that connects two vertices. So using my classification, we couldn't use that as a side. So I would be looking for side, side, side. If I had tick marks on this, we could go side, side, side. Are we good? So you tell me, Alex, then, is it SAS? Can we use SAS? Because the angle is touching both of the sides. Good. And did y'all remember to put the little congruent sign after your SAS? If you left that off, go ahead and put it there, and then put a star next to it to remind you to do it next time, okay? Because that's really easy to forget. All right, now the last 2 here. These ones I'm going to ask you to do on your own. I will gladly come around and support you. Notice in these ones, you have more than just the reasons to fill in. You also have to fill in parts of the bubbles. Okay, so some of you have done this already. I have my answer key for this over on the whiteboard there. If you're finished, I'd like you to come up and check your answers. Okay, but please don't come up and check your answers until you have a best guess for everything in proof number 3 and proof number 4. Ask me questions if you're not sure. I'm more than happy to help. I will tell you that I got fooled by number 4. Even though I made it, I fooled myself. And you'll see because I had to scratch some stuff off and correct my answers on number 4. So, all right, when you guys get this done, you're going to start on the homework assignment, which is the next one in our packet. 6.1.3. No, sorry, 6.1.3, and that's due on Thursday the 9th. All right, and you got a good chunk of time to do that. All right, get after it. I'll be around to support you. If you're absent and you're watching this on the interwebs, those the answers to those problems are on Canvas. Look on Canvas. All right.